Good day, everyone. I hope you're doing well today. Hi, I am Joyous Cortez Suera, a second-year college student taking up a course of Bachelor of Physical Education at Eastern Visayas State University or MO campus. So our lesson for today is all about the Nano World. Our lesson objectives. At the end of this lesson, the students should be able to define nanotechnology, characterize nanoscale, describe the various uses of nanotechnology, discuss concerns on the use of nanotechnology, and explain the status of the use of nanotechnology in the Philippines. So what are you waiting for? Let's begin! Scientific researchers have developed new technological tools that greatly improve different aspects of our life. The use of nanoscale is one important interdisciplinary area generated by advancement in science and technology. Scientists and engineers were able to build materials with innovative properties as they manipulate nanomaterials. Indeed, research and application of knowledge on nanomaterials will continue to bring widespread implications in various areas of the society, especially healthcare, environment, energy, food, water, and agriculture. So class, just as the invention of light microscopes revolutionized human understanding of the natural world, modern microscopes that can reveal and alter individual atoms are once again exposing a whole new world, the nano world. Nanotechnology is aiding and revolutionizing many different aspects of science and industry, including energy, environmental science, homeland security, transportation, food safety, information technology, and medicine. As with any new technology or field of study, it is important to examine the potential for unintended consequences, especially those related to human and environmental health. Nanotechnology refers to the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanoscience and nanotechnology employs the study and application of exceptionally small things in other areas of science, including material science, engineering, physics, biology, and chemistry. So it means that nanotechnology is the term given to those areas of science and engineering where phenomena that takes place. Dimensions in the nanometer scale are utilized in the design, characterization, production, and application of materials, structures, devices, and systems. Nanotechnology is helping to considerably improve, even revolutionize many technology and industry sectors such as information technology, homeland security, medicine, transportation, energy, food safety, and environmental science, among many others. The concepts of nanotechnology November 29, 1959, when physicist Richard Feynman discussed a method in which scientists can direct and control individual atoms and molecules in a stock. There is plenty of room at the bottom. During the American Physical Society meeting at the California Institute of Technology, the term nanotechnology was coined by Professor Norio Taniguchi machining. So it means that nanoscience and nanotechnology are the study and application of extremely small things and can be used across all the other science fields, such as in chemistry, biology, physics, material science, and engineering.
What a great idea!
How small is a nanoscale? A nanometer is a billionth of a meter or 10 degree of a meter. The illustration on the side shows how small nanoscale is other particles or materials. So, just how small is nano? In the International System of Unit, the prefix nano means 1 billionth or 10 to 9. Therefore, 1 nanometer is 1 billionth of a meter. It's difficult to imagine just how small that is. So here are some examples. The illustration On the side has three visual examples of the size and scale of nanotechnology, showing just how small things at the nanoscale actually are. For example, a sheet of paper is about 100 nanometers thick. So, a strand of human DNA is 2.5 nanometers in diameter. There are 25,400,000 nanometers in 1 inch. So, a human hair is approximately 80,000 to 100,000 nanometers wide. A single gold atom is about a third of a nanometer in diameter. On a comparative scale, if the diameter of a marble was 1 nanometer, then the diameter of the Earth would be about 1 meter. And lastly, 1 nanometer is about as long as your fingernail grows in 1 second. Manipulation of nanomaterials needs an adept understanding of their types and dimensions. The various types of nanomaterials are classified according to their individual shapes. They may be particles, tubes, wires, films, flakes, or shells that have one or more nanometer size dimensions. One should be able to view and manipulate them so that we can take advantage of their exceptional characteristics. So how to view nanomaterials? Scientists use special types of microscopes to view minute nanomaterials. During the early 1930s, scientists used electron microscopes and field microscopes to look at the nanoscale. The scanning tunneling microscope and atomic force microscope are just among the modern and remarkable advancement in microscopy. First is the electron microscope. German engineers Ems Roska and Max Nall built the first electron microscope during the 1930s. This type of microscope utilizes a particle beam of electrons to light up a specimen and develop a well-magnified image. Electron microscopes produce higher and better resolution than other light microscopes because they can magnify objects up to 1,000,000 times, while conventional light microscopes can magnify objects up to 1,500 times only. Scanning electrons microscope and transmission electron microscope are the two general types of electron microscope. So, electron microscopy is a technique for obtaining high-resolution images of biological and non-biological specimens. Electron microscopes are used to investigate the ultra-structure of a wide range of biological and inorganic specimens, including microorganisms, cells, large molecules, biopsy samples, metals, and crystals. Industrially, electron microscopes are often used for quality control and failure analysis. So there are microscope, the transmission EM and the scanning EM. The transmission electron microscope is used to view the specimens through which electrons can pass, generating a projection image. The term is analogous in many ways to the conventional light microscope. TEM is used, among other things, to image the interior of cells, the structure of protein molecules, the organization of molecules in viruses and cytoskeletal filaments prepared by the negative staining technique, and the arrangement of protein molecules in cell membranes by phase fracture. So here are some example images using electron microscope. Second is atomic microscope. It was first developed by Gerd Binig, Calvin Quate, and Christoph Gerber in 1986. It makes use of a mechanical probe that gathers information from the surface of a materials. So it means that atomic force microscopy or scanning force microscopy is a very high resolution type of scanning proof microscopy. We had resolution on the order fractions of a nanometer, more than the diffraction limit. Can be used to image the topography of soft biological materials in their native environments. It can also be used to probe the mechanical properties of cells and extracellular matrices including their intrinsic elastic modulus and receptor ligand interactions. So here are some examples of images using an atomic force microscope. Third is scanning tunneling microscope. This special type of microscope enables scientists to view and manipulate nanoscale particles, atoms, and small molecules. In 1986, Gerd Bennig and Heinrich Rohrer won the Nobel Prize in Physics because of this invention. So, a scanning tunneling microscope or STM type of microscope whose principle of operation is based on the quantum mechanical phenomenon known as tunneling, in which the wave-like properties of electrons permit them to tunnel beyond the surface of a solid into regions of space that are forbidden to them under the rules of classical physics. In other words, scanning tunneling microscopy is a technique that has been use structures using the chemical compositions of atoms and molecules in NPS to image surfaces at the atomic level 270. STM was the first technique used to study nanostructure, morphology, and sizes. The scanning tunneling microscope or STM is widely used in both industrial and fundamental research to obtain atomic scale images of metal surfaces. So here are some example images using scanning tunneling microscope. That's all for today, class. I hope you've learned a lot from our lesson and God bless us all.